All right, here we go. Today's work that we're looking at is what we call matching and allocation. So the graphs that are used here are what's called bipartite graphs. Oh, I've got the thing up, just haven't clicked on it. There we go. Called bipartite graphs, bi meaning two, so there's two sides to the graph. So here we go. So as it says, joins two groups. And we set out vertices one on another. So this group of people, Anne, Bob, Cam and Dan, and so there's their vertices. And then we've got three, in this case, animals, elephant, fox, giraffe, and there they are. And so the lines joining up might be, which ones they like or they don't like, for example. So Anne likes elephants, Bob likes elephants and foxes, Cam likes foxes, and Dan likes giraffes. I mean, that could be. Now, there could be a direction on there, of course. I mean, because that could be elephants like Anne and Bob. We don't know, but so it could be directed. So here, for example, here's a directed one down the bottom here. So Helen, drum, Ian, bass and guitar, Jack, drum and guitar, and Lynn, vocal. So person and instrument. So these might be the instruments that these people can play. All right, not the other way around. The guitar playing the person's playing the guitar. All right, so the arrow indicates here a person plays that particular instrument. Not that that particular instrument's been given to that person, you learn to play it. All right, so Helen plays the drums and so does Jack. So if they were putting together a band, they would then need to make some sort of decision. All right, and we'll get to those kind of things in a moment, but first some definitions. All right, the next thing could be weighted, so you could have numbers on these. So for example, there might be 4 employees, each employee can operate each machine, and the weighting indicates the time taken to perform the task. So here's some people in a machine, so person Mark, Neil, Aranthe and Penny, and the machines are cutter, press, folder, spray. And it looks here like that all of these 4 people, they can all operate the machine, but we've got a weighting indicates the time. So Mark up here, for example, whatever particular thing that they're doing might be making, making something that this company is going to sell. So they're making something, and so Mark knows all the steps. He can do all the steps, but the step in making the thing, if he uses a cutter, it takes 30 minutes. If he uses the press on this, it takes 40 minutes. If he uses the folder, it takes 50 minutes, and the sprayer, he takes 60 minutes. And then when you do the same thing for all the people, you got all these numbers and all these lines, and it's very, very confusing. So we need some other way of setting this out. So we use a table. So there's the table. And here we go. Here's our machines, our cutter, press, folder, and spray. And here's each person and how long they take when they do each of those particular tasks. So it could be time, could be money, could be whatever. And in this particular case, I'm using time. So we want to obviously find the most efficient way. So we want to find the way of making this item that's going to be the shortest period of time. So then we can produce more items in a day, get them out, get them sold, and make more money. So how can we work this out? Well, we can work it out. The shortest time to complete the whole job, we use a thing called the Hungarian algorithm. So in my notes on the website there, that are there for download, it goes through and it outlines, and it gives you, here we are, some explanation about each step. I'm not going to write all of that out now. I'm just going to work through that. So if you download the notes on the website, Physics with Synno, if you go to the maths pages and the further maths, you'll be able to find them. So here we go. Here's our employees and our machine and our cutter, press, folder, spray, and there's all our 4 employees. So for the first step, so this is step 1, as it says on the notes there, we subtract the lowest value from each number in that row. So we look at Mark, for example, and we've got 30 here. And so what we do is I take 30 from each of those. So 30 minus 30, of course, is 0. 40 minus 30 is 10. 50 minus 30 is 20. And 60 minus 30 is 30. Then we move on to Neil. And Neil, the lowest number for Neil is 30. So again, we take 30 from each of those. So 70 take 30 is 40. 30 take 30 is 0. 40 take 30 is 10. And 70 take 30 is 40. Next, we step down to the next one, Orianthe. Good guitarist, I've heard. All right, and we look at hers. Again, 30 is her lowest, so we take 30 from anything. 30 take 60 is 30. 50 take 30 is 20. 60 take 30 is 30. And 30 take 30 is 0. And finally, Penny. And when you look here, Penny's lowest is 20, so we're going to take 20 off everything. So 20 take 20 is 0. 80 take 20 is 60. 50 take 20 is 30. And 70 take 20 is 50. And so there's the end of the first step. And so then step 2. We do this. So let me just, before I do that, I'll need to rewrite those. So 0, 10, 20, 30, 40, 0, 10, 40, 30, 20, 30, 0, and 0, 60, 30, and 50. All right, so now we're going to work with this on step 2, and let's see if I can be... All right, change. So then at step 2, we put lines through the columns and or rows that containing a 0, but we want the fewest. So if I do rows, 1, 2, 3, there'd be 4. But if I do columns, there's 1, 2, 3, right? And we want the fewest lines that are going to go through all the zeros. So to get all the zeros horizontally, I've got to go through every row, so that's 4. But if I do it by columns, I get 2 zeros there, I get 1 there, and I get 1 there. So there's 3 lines. All right. So the column without, so step 3. So in step 3, it says for the column without a 0, subtract a value 0 from the lowest number. All right, so that's the number without the 0. All right, so I'm going to go here, go back to my orange, and so I'm looking for the number without the one without the 0. So the columns with the lines in them, I'm going to leave those. So 0, 40, 30, 0. The next one across was 10, 0, 20, and 60. This one over here was 30, 40, 0, and 50. All right, and then this column here, the finishing column, that was the one that doesn't have a line in it. So what we do is we have a look at that and go, okay, so the lowest number there is 10. So I'll take 10 from each of these numbers. All right, so 20 take 10 is 10. I'm going to be scrolling backwards and forwards here a bit. 10 take 10, of course, is 0. Next one here, 30 take 10, both of them are 30. 30 to take 10 is 20, so we got a 20 here and a 20 here. So that's step 3 that we've done. And so now we've got that. All right, and so now we want to, again, put lines, as few lines as possible to go through all these zeros. So let me try and change my colour here to the purple. And so step 4, where we are. Step 4 is going to be in the purple line. Okay, so we want as few lines as possible to go through the zeros. So I can go down there, I can get 2 of them there. I can get 2 when I go across there. And this next one, to get through that 0, I can either go horizontally or vertically. And I'll just go vertically because I've done that in the notes. So there's 3 lines there. All right. So now what we need to do is we need to have a look and see these numbers here, the uncovered numbers we're interested in for step 5. All right. So let me change back. So step 5 here, we're looking for the uncovered numbers. So the smallest uncovered number. So the smallest uncovered number here is 10. And what we do, and this is interesting, so if there's numbers covered by 2 lines, so that's these 40s here, we add this smallest number. So step 5. So their smallest uncovered is 10. So the 2 lines there and there, we add 10. So 40 plus 10 is 50. So that's here. 40 plus 10 is 50. So that's here. And our uncovered numbers, we take our 10 from it. So 10 take 10 is 0. 10 take 10 is 0. 20 take 10 is 10. So there's a 10 there and a 10 there. 60 take 10 is 50. And that other one, 20 take 10 is 10. All right, so that's what we've done there. all our other numbers, excuse me, all our other numbers, these ones here just covered by one line, we just transcribe them. All right, so transcribe them. We've got 0 there, we've got 30 here, 0 there, we had zeros there and there, we had 30 up here, 0 here, and 50 here. All right, so in step 6, which is what I'm going to do, yeah, I'll do it on here and I'll do it a different color. So let's do it in that, oops, wrong one, do it in that purple. So step 6, oops, what am I doing there? Step 6, and step 6 is when we repeat the step 4 up here. So the step 4, remember, was putting the lines, the least number of lines through the zeros. All right, the least number of lines through the zeros. All right, so if I go this way, I'll get 3 of them. That's good. If I go this way here, I'll get 2 of them. And then what else? We've got these other 2. So then I can pick up this one by going there with that, but it's not overly helpful, because if I took this line out, I've got to somehow get these ones. And then I've got this one down here, and I can get that by going vertically or horizontally. And looks like here, there we've got 4 lines is the minimum number of lines. If I go any other way. And so now, because we've got 4 lines, this is where we stop here. So we're wanting our minimum number of lines that we can put through here to be exactly the same as the number of tasks we've got, right? So we've got 4 lines. So we've got a minimum number of lines is 4, and we've got 4 tasks. So this is where we stop. And so now in the next step, step 7, so I didn't actually need those because I've done them. Step 7, what we do is we do some allocations. So mark, we allocate people to things with zeros. So mark we could allocate to any one of these 3 things. So let me go down here. I'm going to have to scroll backwards and forwards here. Hopefully that doesn't get annoying. Let me do this in blue, shall we? So step 7. All right. Step 7. I don't know why it's doing that. Right. So step 7. So we've got our people. We've got Mark. We've got Neil. We've got Oriente. And we've got Penny. And we've got our tasks over here. We've got the cutter. We've got the press. We've got the folder. And we've got the sprayer. So we make some allocations. So we join up. So here we go, up here. So Mark, we join up with zeros. So Mark can do the cutter, the press, or the finisher. So for Mark, we want the cutter, press, or the finisher. All right, let's see what Neil can do. And again, we're joining up. So Neil with the zeros. So Neil, either the press or the finisher. All right. So Neil can do. He can do the press for us, or he can do the finisher for us. All right. So then next, Oriente. So Orianthe, here we go. Orianthe's only got 1 0, and that's the spray. So Orianthe, you can go the spray. And Penny, Penny, only 1 0 here, and that's the cutter. So we'll go here, Penny has to do the cutter. All right, and so now we can do step 8. We can do some allocations from this. All right, so step 8 is our allocations. And so Penny and Orianthe can only do one thing. So Penny has got to do the cutter. No option. So this is for the lowest time, of course. Orianthe, she's got to do the sprayer. So Orianthe, again, I'm going to have to scroll up and down here. Orianthe can do the sprayer. So then we've got the finisher and the press and the folder, I should say, the press and the folder. Now, Mark can operate both of those, so can Neil. All right, so, Neil, he can do either the press or the folder, and Mark, he can do the press or the folder as well. Now, because they were both zeros, these two people, it doesn't matter who, all right? So which one does what, it doesn't matter, because they take the same amount of time as each other to do those particular tasks. So let's just say, for example, I'm going to allocate Neil the press, and I'm going to allocate Mark the folder. All right. So now we need to know step 9. We need to know the costs, or in this case it's the time cost, and we need to know what it is. So Penny with the cutter, Orianthe is the sprayer. I said I'm going to allocate Neil to the press, and we're going to allocate Mark to the folder. So now we need to go way back to the start and find out how much time. So when you go way back to the start, to that first table, this one up here, that told us how much. So Penny, we're allocating to the cutter, and so she takes 20. Orianthe, we're allocating to the sprayer, in which she takes 30. Neil, we're going to allocate to the press, and Mark, we're going to allocate to the folder. All right. And as I said, in the end, at the start, didn't matter which one we do, because with those two people, 30 plus 50 is 80, 40 plus, if I had it the other way, 40 plus 40 was 80. So it's the same time cost for whoever. All right, so now we need to transcribe those down, because there's one I've prepared. Got a sheet of paper sitting next to me. I can figure that out much more easily. So Penny, that was 20. Penny was 20 minutes to do that. Orianthe was 30 minutes to do that. Neil took 30 minutes to do that, and Mark takes 50 to do that. And then when we add that up, so that's 130 minutes, is the least amount of time for us to cover that whole job, make that whole item. All right, so as I said, in the notes on the website, there's more writing about those things. There's also another sheet which runs through which is worded in a slightly different way that runs through the Hungarian algorithm as well. All right, so have fun with all of that. And of course, if you're not sure about stuff, make sure you ask for some help.